You guys have them written down? Okay. One over the absolute value of x times the square root of x squared minus 1. Did I answer your question somewhere in there? Okay. You don't even have to do it.
Why is like sine and cosine paired and secant and cosecant instead of sine and cosecant and cosine and secant? Like tangent and cotangent are paired because they're like opposites, but like the other two are not.
You just heard all my logic for figuring that out.
That's a much deeper explanation than I can remember, or you can understand,
Okay.
or possibly I can understand. We're just gonna go with that.
Okay.
Alright, we good? Got them written down? So that, I mean, you can probably do these problems without me showing you anything. Again, this is not really much of a lesson. And it might take me like one example for you to be like, oh, okay. But kind of the same as the others. I gave you like a day where it's just like straight up, here's the basic rule. Use J rule with it and practice. And these, and so if you remember what we did like the regular trig. It was just like sine of 2x. You guys did a workshop on that. It was basically just help you memorize it. And then we started doing like shit double chain rule and product and stuff with it. And then we did e to the 2x. It was just like a basic chain rule. And then we started combining with product and chain and all that. This, we're going to do a basic worksheet. Like it's just going to, they're almost all going to be like this. I'm just going to change what goes here. These are, I'm not going to say never, but I haven't ever seen them combine an inverse with a product rule or like a double chain rule or a quotient rule. Typically, if the inverse is on there, that would be the question, something simple like that. So if they're basically checking, do you remember the rule? They're not going to ask you to combine it with a bunch of other stuff. So we're not going to be worried about combining these with product and double chain or anything like that. If that helps you feel better. You just have to know the rule. So cosine inverse, the rule is, first of all, it's negative because it starts with a C. The square root of 1 minus. So the rule is like x squared goes there. But that's if I was doing cosine inverse of x. So if I'm doing cosine inverse of 4x squared, it's like a chain rule thing, right? So the little guy goes in that spot. And then what do you multiply by? 8x. So they would probably, so they'd put the negative 8x on top. And they might leave the bottom like it is. But they also could square it. If it's for response, they don't care what you do. I don't care what you do. So you're allowed to leave it in the parentheses like that. They might also square both things. This 4 here, did I get that by doing 2 times 2 or 2 plus 2? Power 2 power, you multiply. So the 4 squared is 16. The x squared, you multiply those, and that was 2 times 2. That's it. I mean, they're not like, it's not some crazy problem. It's just basically, did you memorize these? Because it is a pain in the butt to memorize them. Let's say secant inverse of 8x to the third. I mean, that's the general form of every problem. Something inverse of something simple. We use the rule, multiply by the chain rule, part of it, and you're good. The game is mostly that is the end of the things you have to memorize. Until second semester when you have to memorize those all backwards. But that should be easier because you know forward, hopefully. Yeah, so in first semester's derivatives, second semester's integrals, which is basically So secant inverse, positive because it starts with a C, or it doesn't start with a C. Absolute value of what? Of the 8x to the third times the square root of the 8x to the third squared minus 1, and then times 24x squared. So they would probably do this. Does that 8 need to be inside the absolute value? It does not. So that's a positive number. So they would probably take it out and cancel and say that's 3x squared on top. But the x to the third does need to be in there because could the x to the third come out positive or negative? It could. So we do need those absolute value signs. If that was an x squared in that absolute value, would we need the absolute value signs? No, because x squared is always positive. So at that point, they could remove them. And again, you don't have to do that, but you have to like understand how, if that's a matchup on a multiple choice. And then they might just leave that like it is, but if they did square it, let's just make sure we know how to. So that's 64x to the what? 6, because you multiply them. And then minus 1. And if you left the 24 and the 8, you'd be totally fine. Again, I'm just trying to get you to like recognize things to match up with the multiple choice. Questions on 2? I got nothing else really. There's not any other fancy things I can do. I don't know. Cotangent inverse of x to the 5th. Calculus is the hard part here. A lot of times it's the algebra, the seventh, memorizing. Check, is that part of your Halloween costume? Is that why? Is that why the head is supposed to be alive?
I guess so, yeah. Tell him to take it off. It's written on his head.
I'll allow it. Why would his misery make you happy?
I don't know.
Just what?
It's just my own deal.
It's alright. So positive or negative? Positive or negative? Negative. Starts with a C. And then it's, I can't remember if I wrote x squared plus 1 or 1 plus x squared, but it doesn't matter. So I'm going to go 1 plus x to the 5th squared times 5x to the 4th. And so then they would simplify that and say, okay, that's negative 5x to the 4th over 1 plus. So they might leave it like that, but if they did multiply it out, it'd be x to the what? 10th. Because you multiply. And that's your answer. How many have that? So nothing crazy, right? It's just a matter of are you going to memorize them or not? Like that's the whole game. So these are problems that I don't expect the problems to be too difficult. Hopefully not. It's just helping you practice and do the derivatives over and over again to hopefully get them stuck in your brain a little bit. Remember, it's fair game for me tomorrow on those 16 things. I'm not saying I will or won't. I'm just saying anytime after that, I'm allowed to. Starting tomorrow. Tomorrow or beyond.
Yes.
Are you booing? I don't think I've ever been booed in class before. It's kind of flattering.
One time I just started wondering when I was crying.
What, like, because you were doing it wrong or something?
No, okay, no.
Did you form stock?
No, I left like 5 seconds early and then I just stopped. And I knew the